All right, we will start in a couple more minutes. Stay tight, and we'll start soon. Do you see the recent post about that? I see it. Yeah.
Right, alumni network.
Um, and so we're playing an alumni panel, not order, right?
Alumni
Panel. That's right, right? Never mind. I'll talk to you about that later. All right, cool. I think let's start. All right, everyone, welcome. Good. Yeah, good job. What? Oh, yeah, I'm a bit of a mess. Everyone, thanks for coming. Today we'll be going over picking classes. This is a collaborative event between ACM and Google Developer Student Club. Before we get into the picking classes, we'll go through a quick showcase of the Creative Code Collective.
Do you hand me the? Hi, everyone. My name is Samir Ghosh. I am a PhD student in computational media. I'm a VR researcher. My research concerns putting scientific simulations inside of VR, but I'm not here to talk about that. I'm here to talk about the Creative Code Collective. It's a huge organization beyond me. Like, it's kind of like an underground thing with lots of professors and industry people. Like, I was able to do Google Summer of Code because of contacts over here. Like, virtually all my career stuff came out of like contacts from here, and it's really, really fun. Code is usually a very stressful thing because we do it in the context of class and for assignments and super boring. Or if you get an internship, you're just like crunching data or pushing like whatever, but it can be really fun. Do it. Do the thing. Slide. All right, I'll just sit. All right. What is Creative Code? It's so many things. So here's a couple pieces I worked on for a fashion designer. This is a piece called Caress of the Gays. I'm just going to roll it and hopefully it rolls. And it's this piece with porcupine spikes all over it. And it's supposed to be about male gaze. So whenever you look on it, there's these like cameras that are hidden in the suit. They're really, really tiny. It uses machine learning or whatever, and it like looks at wherever the eye looks on the body, and it calculates that, and it uses pneumatics to like porcupine spike it and like poke it outwards. So like she has these really cool like pieces that commentate on surveillance or feminism and whatnot. And like, yeah, it was a whole thing. And I worked on a lot of the Arduino and embedded systems things over there, but it's creative because you have to like come up with all these challenges. So that was like a thing. I studied linguistics in undergrad, but then this was just like, nope, you're going to go into another career path. So, and then one piece I worked on a lot was this piece called Bodyscape, which, oh man, I don't have time to explain it, but this piece is this material is extremely brittle. You put any sort of force on it and it would just instantly snap. But she uses a data set that surgeons have about skin tension throughout the body. So she uses that to figure out what exact structure you can make so the model can move on the runway and it doesn't put any force on the piece. And I did like these generative lighting patterns and like safety stuff so it wouldn't like hurt the model. But that's like one aspect of Creative Code. There's stuff right out of Santa Cruz, as you may have seen, is a very creative community. This is a professor and a PhD student that made this like freaky photo booth, and they set it up at parties. You take a photo, and then it like makes a fun neural image, and it's like all sorts of wacky stuff that's made out of it. I have a peer named Lauren who like streams VR with graphics code. So she like dances in VR in these like VR nightclubs that are like lit, and like she uses code to make these cool trippy patterns all around her. I myself, like in the modern day, I just make like generative art. So I use different libraries just to make fun patterns. Like in class, I used to just doodle. It's literally called sketching in this community. So like I just like tune out of the CS lecture and just be like, I'm gonna make some patterns. And it actually worked out really well for me. So and then some people, like a peer of mine named Catherine, she thinks about code as a language. Like she finds a lot of beauty in the structure of these programming languages. And she actually made her own, like from the compiler and interpreter everywhere, she made like a language and is thinking about these like regular expressions, ambiguities, strings, and code as text. And she's like published in this now, and she works as like a data visualizer and stuff. She's really cool. And a lot of people in this community think about criticality and empowerment. They work on like the cutting edge of AI research, or they think about all the problems with AI that we have now. So like this is like one aspect of a lot of the ethical people in the field that are very tied to these artistic and creative communities. So anyways, I am working like under the guidance of these people to try to instantiate a little bit of that here in UC Santa Cruz. Slugworks is helping me. Some professors are helping me. Some of them show up to these meetings too, which is kind of nice. So yeah, here it is. You can take a quick gander. I have a really jank email list that originally was for like VR stuff too, but I'm going to send out events. Right now I'm thinking it'll be the first Wednesday and maybe the third Wednesday of every month. So if you're interested in these sorts of events, I'm going to be sending them out through here, and I'll leave it up for like a minute. So if you want it, you should take it. So yeah, thank you so much for having me. This is like courtesy of a connection through her and like through Slugworks. So if you haven't checked out Slugworks yet, you ought to. That's like a special thing that UC Santa Cruz has. Like how many millions of dollars poured into it, and people up and down the state went to make that institution just for you. So keep that in mind. But yeah, did everyone get a chance of that email list that wanted to be on it? Yeah. All right. Thank you so much. Have a great meeting, everyone.
All right, we'll begin with the remainder of the meeting. This is again about picking classes with ACM and Google DSC.
All right, so we'll start with a couple of announcements from ACM first. So as always, we're still continuing to do resume reviews. I've given this spiel a couple of different times, and I see some familiar faces in here have probably gotten this spiel too. But just in case you are new here and you haven't gotten this spiel, you can get your resume reviewed for free by us here at ACM on the student team. Upload your resume to the tiny URL here, tinyurl.com/resume review sheet, and make sure you turn on link share with organization and comment access. Otherwise, we will not be able to comment, and we will defer your application to a later date until that issue is resolved. So again, if you're interested in getting your resume reviewed, please use the URL up there. Give you guys a little bit of time. Yes. All right. Additionally, we are still holding leak code sessions Friday 6 to 7 in E2 180 in partnership with all these clubs here, Sky, ACMW, SHIP, and AutoSlug. And it's open to all skill levels. I believe we are going to be off for Thanksgiving break and then off for another week. Mm-hmm. Right. And then last but not least, ACM is hosting a game night tomorrow from 7:30 to 9:30 in Humanities 210. I don't know exactly where that is on campus, but you guys can figure that out. But yeah, for those of you that have just finished up midterms, come here, have a chance to, wind down. We'll have some fun and games. We'll be doing some trivia, and we'll be doing a little marshmallow and spaghetti kind of event, work on team building and collaboration, all those sorts of things. So yeah, I highly suggest that you come show up to that. It's tomorrow, 7:30 to 9:30. And in terms of our schedule of events for the rest of the quarter, week 8 is going to be off for Thanksgiving break, as I mentioned before. Week 9, we are very privileged to have some professors come and do a little bit of a speaker event with us. So if you're interested in coming to that event, be sure to have that down in your calendar. It'll be the same timings as our normal meetings. And then finally, week 10 will be off just for finals preparation, so everybody can get that last little hour of studying if they so need it.
Hi, so for DSC events, we're also going to have week 8 off for Thanksgiving break, and then we're going to be having 2 events as usual during week 9. So the first one is going to be a solution challenge team finalization. So we've been having our solution challenge events every 1 or 2 weeks, where people come, they talk about their ideas, they present. So this is going to be more like a finalization and then team bonding as we prepare for the actual solution challenge event starting in winter quarter. We're also going to have a GitHub 101 workshop. This might sound really basic. I promise it's more than just how to use GitHub. A lot of people know how to use GitHub, commit, all of that stuff, but people are not used to working in a group. And so we're going to have a special activity where you do get to work in groups and use GitHub. So I think you should definitely come to that.
All right, and we will go ahead and start.
So this is the general CS degree curriculum sheet for those who are sophomore and juniors. But then one thing to note for those who are freshmen is we actually have a new course called the CSE 101M, and nobody knows what that is. But then the good part is for operative electives, you only need 3 instead of 4 compared to those who are like sophomore and juniors. And then here are the required lower div classes for CS people. So in general, that is like 2 required Python class, and 1 is like you're messing with map notations. And for CSE 12 and 13S, you're learning how to program with computer systems. Yes, and then for math courses, there's calculus and linear algebra. And then for EC 30, that's like physics heavy. And then we also have the required CS operatives for the CSE 101, 102, and 103. These are the algorithms. And if you're looking for sweet interns, you should really pay attention to CSE 101. And then for 120, 130, 114A, that's like very courses. For CSE 107 and Stats 131, these are the statistic classes. Yes, and again, so for CSE 101M, this is only for freshmen. They're like really new.
Okay, so those were the requirements for if you're a CS major. If you happen to be in the same boat as me and you're a computer engineering major, you have a couple of different change-ups in the way that your curriculum will look. As you can see up here in your sort of lower divs and the core courses that you will take, you have some extra classes sprinkled in there more for the engineering side of it. And then in addition to that, you also have the chance to pick your own concentration to go into, which is actually specified on your graduation diploma. We'll get into that a little bit later. And so essentially, you'll have some of these same lower division courses, you'll have, Math 19A, Math 19B, that's covering your math courses, AM 30 or Math 23A, AM 20, that whole series. Again, same math that you'd probably be taking as a CS major. Again, you'll have CSE 13S, another important lower division course that all like computer science related people will take here. But as you can see at the very bottom here, we have physics 5A and then 5C and then 5, that should be 5B and M. So that's basically your entire physics series that you'll be taking since you're going the engineering path. And then for the upper division courses, you can see we have some familiar courses in here. We have 101 Intro to Analysis and Algorithms, 120 Computer Architecture and whatnot. But in addition to that, you'll also have some, you'll have CSE 100, which is Introduction to Logic Design. And then you'll have your ECE 101 and 103, which is your like signals and systems and circuit building and stuff like that. In terms of your electives, your DC requirement is satisfied because all of us here have to take 185E or S. I believe for computer engineers, we have to take 185E. And then specifically for computer engineers, we have the 4 concentrations and 1 capstone series that tells us, which electives we can take. Yeah. So here, as stated before, computer engineering requires you to have an official concentration. So for computer engineering majors, when you have to declare by your 6th quarter or your 7th quarter, sorry, here at UCSC, you will have to select one of these 4 concentrations at the top. So that's computer systems, systems programming, networks programming, and digital hardware. Again, you'll have to choose that when you declare, but CS does not have official concentrations. So the way that you go about specializing or being like, okay, hey, what's my real interest? What courses do I want to take later on in my 3rd and 4th year? Those are just dictated by what classes you take. And some of those tracks include, web development, front end, back end, AI and ML and data science, or video game design, which is its own major again, but we won't be getting into that today. So I'll go ahead and cover the first 4 specializations since they're officially declared by UCSC. This goes for only computer engineering majors, but again, you guys will also have access to most of these classes as electives if you're a CS major. So if any of these classes do interest you, I suggest that you take them if you wish to. So starting off, we have computer systems. So this is the specialization where you're focusing on the interactions within, the entire computer systems to say. So this is like interactions between, your CPU, RAM, memory, stuff like all that. You'll be going more into depth about that. Systems programming is a subset of computer systems, but here you're focusing on literally like programming the low level software of these machines. So if you think about classes like CSE 12 and CSE 13, where you're learning assembly and C, those are like the main types of work that you'll be doing with, and those are the types of language that you'll be dealing with. So very low level, close to the machines. And then we have networks programming. So networks programming, it's completely separate from computer systems and systems programming. It focuses more on writing software for machines to communicate across a network. So you can think of these examples of, if you have a smart thermostat in your home. So like if anyone, just by show of hands, maybe you have like a Nest Hub in your home, or maybe you have like a Google, Alexa, Echo Dot, something like that. Yeah, so that's essentially the premise of networks programming. You'll be writing software to program the communications between those sorts of machines. And then finally, you have your digital hardware. So this is literally just the development analysis of electronic circuits and components. So this is quite literally creating all of the stuff that we work on today. So this includes stuff like, chip design, also encompasses stuff that comes with, robotics and mechanical engineering. Right. So as far as the classes that you can take with computer engineering and these specializations, you'll see some overlap, but you'll see that there's also like multiple like distinct courses that you'll take in each specialization. So here in computer systems, you can see, you have your 115A, which is, it's a capstone that most people are required to take, Introduction to Software Engineering. You'll have CSE 120. This is a elective or course that will be made available to all majors to take. But then you'll see here, you'll have courses like CSE 122, which is your introduction to VLSI, digital system design. VLSI stands for very large scale integration. That just is more stuff on chip design if you're interested in that. Then you'll have CSE 125, logic design with Verilog. So this is, I believe, follows up after taking 100. And then you'll have CSE 134 and CSE 130, which basically, solidify like programming skills in communicating across systems. So one thing we'll be breaking down, the different courses that each specialization has, and what to do outside of the classroom for each specialization. So outside of the classroom for computer systems, one thing you can do is do a project, obviously related to your concentration. Yeah, you can build a simple OS. That sounds really complicated, and it does require a lot of background knowledge and a lot of research that you have to do firsthand. but something a little bit easier, a little bit more of a step down that most of us can process is, work with microcontrollers and microprocessors. So these are things like working with Arduinos, Raspberry Pis, doing projects related to those. And one thing you can also do is explore research and professors here, because a lot of the professors here, while you may not have some clubs that are specifically focused on computer engineering, there are a lot of professors here that are still doing research on it. So professors that are teaching courses like 120, so Professor Litz or Professor Nath, they will have research and their own set of research papers related to all of that stuff. So if that interests you, we have here, it's a tiny URL, UCSC CSE research. That's just takes you to the School of Engineering page where you can view all the professors doing as such. So go ahead and yeah, so here, if you go on this page, computer science and engineering research, you can go see here if you're interested in computer hardware, systems programming, computer systems. You can see, we have, if you're interested in VLSI, you can go under here and you can see all these different faculty that are doing. So I mentioned before, Professor Litz, Professor Knopf, Professor Rennell. All right, so now for the systems programming specialization. Again, you can see some of these classes, again, like I said, will overlap. So here, CSE 130 is a common class that you'll be taking. I believe it's present in three out of the four concentrations for computer engineering. I think the only exception is digital hardware. You don't need systems design for that. Moving on. Yeah, so it's pretty much the same sort of protocol if you want to do stuff outside the classroom for systems programming as computer systems. But one thing I would really stress here is to really put in some time and effort into learning languages like C and assembly, because those will serve as your basis for building your experience of systems programming on. And again, you can use the tiny URL to look up